Hello, and welcome back to our class of Eurocode 7. This is the second video of this program. I will try to make the video very short so that it will be easy for you to understand. Okay, so this program is all about geotechnical design according to Eurocode. Okay, so I think in the first video we did this first chapter and the introduction of the chapter number 2. Okay, so this video also is about this chapter number 2, basis of geotechnical design. We will try to do this chapter maybe at least 3 videos on this chapter number 2. This video being the video number 2. Okay, that means we'll have at least one more video, or maybe 2. One to finish the chapter, and the third video will be based on example, how to design, how we apply this chapter in design. Okay, in last video we have talked about this number 1, and in this video we will touch these 2 points: design requirement and action and design situation. So 2 points in this video. Okay, so let's start with the first point of this video, which is design requirement. I will try to be very short, to make this video very short. Design requirement. What are design requirements in Eurocode? So as you know, Eurocode design consists of principle, fundamental statement, analytical model, and requirement. And all these must be followed when no alternative is allowed. Okay, we have to follow all these. Complementing these requirements and these principle, fundamental, and analytical model and requirement, we have also application rule, and these are widely accepted guidelines that align with the principal demands. And adhering to this Eurocode's assumption to ensure compliance with construction product directive and successful. So these assumptions involve proper maintenance, accurate use with design assumption, specified construction material and product, selection of structural system by qualified person. Not anyone can select it. Qualified person should select the structural system, and skilled execution, supervision, and quality control. So if you have this in mind, it will be easy to work. Eurocode 7 includes several requirements, and regarding the management of complexity. So the EN 1997-1 emphasis is tailoring geotechnical investigation, calculation, and checks to project complexity and risk. So for straightforward tasks with low risk, qualitative study is enough. This is when you see something in bracket, it means reference to the Eurocode, to the book. You can check in the Eurocode book. So for simple project, we can use just simplified design and procedure. Only we don't need to more complex design for simple project. Okay, so to assist the application of this principle, the Eurocode 7 introduces geotechnical category. There are 3 categories according to the risk and complication of any project. Okay, it's very important for you to understand this because this is the basic of design. You need the requirement. So, for example, category, as I told you, there are 3 categories: category 1, 2, and 3. The category 1 is just for small and relatively simple structure with negligible risk. In that case, the design requirement, if negligible risk of instability or ground movement. Ground condition known to be straightforward. No excavation below water table or such excavation is straightforward. So this kind of thing requirement. Okay. If you have this kind of structure, this kind of situation, you can do just routine design, construction, and design and construction method. Very simple. Number 2 is kind of intermediate and getting more complex. This number 2 category is conventional type of structure, like foundation with no exceptional risk or difficult soil or loading condition. But the size of structure is considerable. So in this case, we need quantitative geotechnical data and analysis to make sure that fundamental requirements are satisfied. And here also, as well, routine field and lab testing. So as you see here, we don't need to do lab field or lab testing. And we do also routine design and execution. Nothing exceptional. When it comes to category number 3, it is more complex one. Structure or part of structure not covered above means one part of this the structure or the structure the entire structure is not covered by these 2 categories. In that case, we need to include a in that case, we need to include alternative provision and rules to those in Eurocode 7. So this means that Eurocode 7 also doesn't cover everything. Sometimes you need to go beyond this Eurocode 7. And this is the reason even why the code will be revised actually from time to time to take account of some new situation that might arise. Okay, I will put just this here, this three category. Okay, but remember that anytime you are doing geotechnical design, you need to categorize your structure. In which category? If it's here number 1, then maybe you don't need to do very serious work. Number 2 is also okay, but when it's come to number 3, then you need very serious work and sometimes very exceptional design that goes beyond the Eurocode 7 itself. Let's take example of category number 2, some example for geotechnical category 2 that will include like spread footing, rough footing, spread foundation, sorry, rough foundation, and pile foundation. One example. Another example is wall or the retaining walls or over structure retaining or supporting soil or water. Excavation, bridge pier and abutments, embankment and earthworks. In ground, we have also ground anchor or over tieback system. Tunnels in hard, non-fractured rock and not subjective to special water tightness or over requirement. So all these are category number 2, geotechnical category number 2. Okay, so how about category number 3? If you have, for example, a very large or unusual structure, then it is category number 3. If we have also a structure that involves abnormal risk, unusual or exceptional difficulty ground, or loading condition, that also will be category 3. Structure in highly seismic area will be also category 3. And structure in area of probable site instability, persistence ground movement, landslide, for example, that require separate investigation or special measures. This also will be category number 3. Okay. So this is, for example, chart flow you can use to detect in which category your structure should be classified. Okay. And the example are here. Category 1, no example. Category 2, example is here. The example we talked about before in the previous slide: spread footing, rough foundation, pile foundation, wall and over structure, excavation, bridge pier and abutment, embankment, earthwork, ground anchor, and over tieback system. All of them are here, I think. The category number 3 is structure or part of structure which do not fall within the limit of geotechnical category number 1 and number 2. So exceptional. So you start here asking yourself this first question: is your structure small and relatively simple? If yes, you can go here. If no, you go this way. Okay. And if your structure is simple, small and relatively simple, yes, you go here. And then after that, you ask yourself again, are ground conditions known from comparable local experience to be sufficiently straightforward that routine method may be used for foundation design and construction? If no, then you go this way. If yes, you continue. If excavation below water table is involved, does comparable local experience indicate that it will be straightforward? Okay, if yes, you continue. If no, you go there, this way. So is there negligible risk in terms of overall stability or ground movement? If yes, then your structure is category 1. If no, you go this way. Then it's something like that. Is the structure very large or unusual? Yes, then it will be here directly category 3. The size of structure is enough to make it category 3. Only size is enough. If no, you go this way. Does it involve abnormal risk? If yes, you go this way. If no, this way. Is there unusual or exceptional difficult ground? So anyway, I think you know how the flow chart works. So by using this flow chart in any geotechnical project, you can categorize your project, your structure. Okay. Then the process, the design process can be done by following these steps, step by step. Okay. If you see any number in bracket here, these numbers, they refer to relevant section of clauses in like Eurocode, but this one is mainly British standard. Okay, but in Eurocode also say it doesn't matter where you are. So first, establish preliminary geotechnical category of the structure. Okay. After that, the following step is preliminary ground investigation and check the geological category. Okay. Then you move to design investigation. If that is complete, you go to check if there is sufficient information. If yes, you can continue. If no, you go for investigation again, design investigation again. If it is yes, you continue here. Okay, ground investigation report and check of the geotechnical category. Okay, then we continue again. The same arrow will continue to here with this design by calculation. You do analytical method or numerical method, but you calculate design by calculation and prescriptive measure, load or model test, or observe. You can observe also observational method. And after that, the following step is geotechnical design report and reassessment of geotechnical category. And after that, the last step, supervision of execution of the work and reassessment of geotechnical category. So these stars means signify where category is checked. So after this step, you can check which category your project is, your structure is. Okay, and you do again these steps. After that, you check the category, which category number 1, category number 2, category number 3. Here also you check. Here as well, you check the category of your structure. Okay. Okay, let's go to action now. Action and design situation, which is section number 3, this chapter. So design situation are set of physical condition representing the real condition occurring during a certain time interval for which the design will demonstrate that the relevant limit state are not exceeded. Okay, they are classified as follows. We have persistent condition. Persistent condition, that is the normal condition in normal use when we are using the structure. Okay, we have also transient. That one is temporary condition. Example, execution of or repair when we want to repair the structure. That is just for a while. not the whole life of the structure. Transient. And accidental, that is exceptional condition, just happen in accident. And seismic one is exceptional condition during earthquake. So if we take this, for example, the persistent one, that one is applied during a period of the design working life of the structure. Means the whole life of the structure. This is this persistent is supposed to be applied. Okay. And for this one, transient one, the period is normally much smaller than the DWL, the design working life. It is temporary, maybe few months or during the construction time, that all, maybe. Accident one, we'll give some example. For example, fire, explosion, impact. Impact means, for example, something come and hit the structure. And local failure. Okay, seismic one, we don't need to explain. I think everyone got it. It related to earthquake, during earthquake. Yeah. So less severe value of partial factor. This partial factor, we will talk about this later. This is also very important, and it depends on each country in Europe. So these partial factor are recommended in the Annex A of Eurocode and may be used for temporary structure or transient design situation when the likely consequences justify it. And the reference is here. Okay, this table summarizes the classification of action according to Eurocode 1990. We have permanent action. The type of action are here: action, permanent, variable, and accidental. Permanent, the duration is likely to act through reference period. This action is like always there. Okay. The variation, it doesn't change too much, can be neglected. For example, we have self-weight of structure. That one doesn't change too much, and it is during the whole life of the structure. Fixed equipment and road surfacing and direct action caused by shrinkage and uneven settlement. This is just few examples. Variable action, and the symbol is also very important. For example, permanent action, you have G, and the variable action is Q. Accidental one is A. Okay, so for variable action, the symbol is Q, and that cannot be neglected. Okay, for example, imposed load on building floor. When you put something on building floor, beams and roof, wind, snow, these are changing. For example, wind is not fixed. Sometimes the wind is strong, or sometimes typhoon. Sometimes it snows. The weight of snow on the roof. Okay, these variable action mainly are on the roof, on the top of the structure. I'm saying roof because I'm referring to building, a house, for example. But sometimes it is not only, it is not a room, a house. So accidental one, the symbol A, usually very short, like earthquake, or the magnitude is significant. Explosion, vehicle impact, seismic, due to earthquake, for example. Okay, so this action and direct action may be permanent or variable also. And this vehicle impact or seismic or snow or wind, they may also be variable or accidental depending on the statistical distribution. Means wind or snow can be sometimes considered as accidental. A, for example, here. And here also, impact or seismic load can sometimes also be considered as variable here. Okay, this situation. So that's why we have this star on this star. But usually it's like this. I think it's the end of this video. So step by step, I think we will finish this problem. Thank you very much and see you.